So our first speaker for this splash talk session is Professor Shivasubramanian Gopalakrishnan from Indian Institute of Technology, Bombay, and he will be speaking on higher order nodal discontinuous Galerkin methods in OpenFOAM.
Right. Thank you. My name probably took up half a minute. So I'll get started quickly. So I changed the title a little bit. It's now called Scalable Simulations Using Discontinuous Galerkin Method. Obviously, the motivation is that we have larger and larger complex simulations, so we need to do really massive calculations, different fields of interest. The main idea here with the discontinuous Galerkin method is that it's kind of a combination of finite elements and finite volumes. You still get the C0 discontinuity between elements, but what you have is higher order polynomial approximations within a computational element. Now, this has certain advantages from a computing perspective because you get higher orders of accuracy locally rather than going remotely. Okay, I'm not going to go through the math. I made the cardinal sin of having 14 slides for 3 minutes when I tell my students, you got to have only one per slide. But these are essentially the nodal basis functions which kind of approximate the solution within each element. Now you could have, so far we can have hexahedral elements, we can have tetrahedral elements, we can have some transition elements, and we are able to construct elements for complicated geometries. We still don't have arbitrary polyhedra like the way it is there in OpenFOAM. By the way, a disclaimer, I've not implemented any of this in OpenFOAM. It's all just standalone codes so far. My hope is that I will have some synergy with groups who are implementing DG in OpenFOAM and get started with this work. So again, a little bit of math. So just to give you a quick idea, let's say that if I want to go a higher order in finite volume, and that black dot is in the center of a CPU boundary, the information needs to come deeper and deeper. So what happens is that you're doing more communication, and so that indirectly affects your scalability. So typically, this is a sparsity pattern of finite volume systems. You can obviously do some reordering and make it more banded, but this is how it looks in DG. So this is really very effective in terms of computing / communication ratios. Just to show you some scalability, this is some work I did about like 10 years ago. We got some nice linear scalability up to like 32,000 processors. So I could not go beyond 32,000 processors because I did not have any more processors at that point of time. Groups of that. Okay, down to 20. The best part about DG is that you get this spectral convergence. So you, as engineers, we care about error. We could get to the error quickly with lower number of flops and hence low amount of energy. My goal is to implement this in OpenFOAM. There are open positions in my group with funding which is starting right now. Thank you.
So our next speaker is Mr. Iason Tsiapkinis from Leibniz Institute, and I think he will be talking remotely, and please unmute yourself. And he will be talking on object-oriented meshing for complex geometries using blockMesh.
Yes, thank you. Can you hear and see me? Hello?
Yes, we hear you and we see your presentation.
Okay, perfect. Okay, let me share my screen.
No, just say next slide and the operator will put you to the next slide.
Oh, okay, that's fine. That's fine. All right.
Okay.
Yeah. Thank you for having me. My name is Jason. I'm a PhD student at Leibniz Institute for Crystal Growth in Berlin. And together with my colleagues, we worked on 2 Python libraries that make meshing and mesh atomization with blockMesh and Gmsh easier using an object-oriented approach in Python. So these tools manage the numbering of the points, the orientation of the surfaces, and the connection between the blocks and regions. And in this way, it helps the user, it helps us to focus on the most important point, which is generating high quality meshes. Yes, next slide, please. Okay, perfect. So the first tool I want to show you is NemoBlock. That is a Python package to generate the very cumbersome blockMesh dict. It manages block connections and topology and also mesh grading. Here's a simple example, which you can see. Yeah, I'm going to point to now, but you can see a simple example of 2 blocks and the code for that. On the right side, we first generate a block object out of the 8 points that define the block. We define the number of cells, and we can add additional edge types like spline that defines the bottom edge that you can see on the bottom block. The second block can now sit on top of the first block, and we only have to define the other 4 points on top. And then we only have to define the grading in one direction, since we get the other gradings from the bottom block. Yeah, we can also define simple patches, as you can see here, with the patch type, and the inlet patch is then simply the bottom face of the first block. And like this, you can generate complex 2D and 3D meshes with 7 or 27 blocks, like you see there in the examples. Next slide, please. Yes, thank you. The second tool is Object Gmsh, which is a Python library implemented on top of the Gmsh Python API with an object-oriented workflow. We can define surfaces and regions and all that without being bothered by geo IDs. And we can set multiple mesh grading constraints, multiple mesh gradings, like you can see in the complex 3D example on the bottom left. And we started developing this for an FEM mesh generation, but we have some additional functionalities for OpenFOAM, like the axisymmetric wedge type you can see there. And for that example, we just define our shapes, the crystal, the melt, the crucible, as 2D or 3D, and then we can make the wedge and write our boundaries and can set mesh constraints for the different shapes or some line or some interfaces. And this creates the mesh that is ready for Gmsh to form. Yeah, next slide, please.
You've got 30 seconds.
Okay, thank you. Yeah, that's all I want to show you. This tool enable us convenient automatic geometry generation and modeling, and for structured and unstructured meshes without the hassle of the technical details of the point numbering and stuff. And yeah, so you can find all the code and the examples on GitHub, and can install the packages via pip. And we hope we are open for suggestions and any questions you might have. Thank you.
So hello, everyone. Hello, everyone. My name is Chandan. I'm currently a postdoctoral researcher at the University of Edinburgh. And today, my 3-minute talk will be completely the talk will be completely detouring from the technical talks that you heard, like the previous one. So today I'll be talking about promoting the uses of OpenFOAM through a government-funded project FOSSEE in India. So the background comes from the fact that I did my master's and PhD in Indian Institute of Technology, Madras. And when I started doing my PhD with OpenFOAM, I really faced a lot of difficulties, and the learning curve was very steep. So currently, my effort with the team in IIT Bombay, Indian Institute of Technology Bombay, with Dr. Janani and Professor Chandan, that we should basically give the basic minimum knowledge and guidance to the students, not even only in the premier institutes, but all in the general level, state level colleges in India, so that they can easily start with OpenFOAM and they can go ahead developing their own solvers. But the problem is that before they go into the level of development new solvers, they're stuck at the level of installation of OpenFOAM in different environment, because the problem while giving some of the workshops, I face that they basically they are not very comfortable with the installation of OpenFOAM, let's say in the Unix environment. So, and they're not very comfortable with the command line interface, let's say. So for that, the main aim of this project would be to promote the uses of OpenFOAM, but not only with the material, but with the proper guidance. And as part of this project, which is funded by the government of India, we have quite a few objective or aims to be delivered. So first one is the case study project, where through the case study project, what we try to do is we encourage PhD and master students to take a problem from a published journal or a textbook problem and to validate it using OpenFOAM, and then we create repositories for these tutorials, which can be useful for the other students who are in the beginner level. Then the next one is spoken tutorial. This is in the format of around 10 minutes of tutorial, where we do basic level of OpenFOAM tutorials for the beginners. And the third one is the research migration project, and the lab migration project is that, like, people who are using commercial software, slowly we encourage them to use OpenFOAM. And the last one is the textbook companion project, where we basically encourage the use of OpenFOAM in the fluid mechanics courses to reproduce the results of the problems that we solve analytically in textbooks. And these are some of the progress, and that's all. So we hope that more and more Indian students will be able to use OpenFOAM in future. Thank you. Introduce you.
Okay, hi, I'm Gerasimos from the Technical University of Munich, and observing the OpenFOAM community, as well as other communities, I can tell you that the OpenFOAM community is awesome. And it's at least as awesome as many of the communities you may recognize on the right. However, looking at the communities on the right, you can see that you get the impression that looking at their online presence, they're much more active nowadays. And it also feels like the underlying software is much more actively developed nowadays. So what do they have in common? First of all, they have, I believe that's one of the reasons, they have a well-defined official online forum for their community. And this is also based on a common technical system underneath that is called Discourse, which is an open source forum platform which you can host yourself, meaning you can have a forum.openfoam.com, or if you just want to try it, you can just ask for hosting, which is free for open source projects. So I have nothing to do with it. I'm just using it for our own software project, Precise. And in this QR code, you can find more about my experience with it after the first year. We're running this for 2.5 years now, and we have almost 300 users there. So how does it look like? It is a classical forum with categories, threads, publicly available, and everything. It's just in color. What does this mean? It has a great search engine by itself, minimizing moderation effort. It has great code highlighting for configuration, errors, and so on. You can mark the solution in a thread to find more easily what you need. It has great integration with GitHub. You can link to posts, to code or issues. You can typeset LaTeX equations as well as everything else in Markdown. You can give complete structure. You get suggestions when you're trying to ask a question that has already been answered somewhere else. You get great tools to moderate and analyze your community. We are using it as a poster session in our workshops, and you get a great mobile view. So my point here is that if there is an official lead for essentially a forum.openfoam.com, people will join, and this will be a nice, colorful, modern home for the next 30 years. So if you build bridges, people will come. Thank you very much.
So our next speaker is Dr. Eugene de Villiers from NGS, and he will be talking about Quantum CFD, a Horizon Europe RIA project.
speaking into this? Yes. Oh, I'm speaking. Oh, go, right. So I'm going to say a lot of words together that I don't understand today. And so just excuse that part. So this is a newly announced European project on making quantum versions of CFD algorithms and running them on quantum hardware. Next. So it's a 4-year project with a whole bunch of mostly universities that are contributing to this. And the project lead is a chap called Professor Dieter Jax at the University of Hamburg, very clever guy. Yeah, so still have a lot of time. So why QCFD? Why do we want to do something as crazy as trying to run CFD on a quantum computer? Number one, the European Commission wants us to do it. So it's quantum computing algorithms is a huge priority for them because they see it as strategic ambition in a field that's rapidly developing. The other thing, quantum computers are actually getting better. IBM has this 127 qubit Eagle computer that can actually do some things if it can stop having so many errors. And then the actual theoretical underpinnings for running CFD on quantum hardware is starting to make sense and people understand how to do this. So it seems like it might be time to give it a shot. This is the how it's done. And this is the part I really don't understand. So I'm not going to try and explain it in any detail, but suffice to say you have some kind of network. If you think about machine learning type networks, it's not like that, but it's a nice way to think about it. And you have coefficients, and then you use some kind of annealing process to minimize the error, the residual in that in a quantum variational network. And that, all these things are words, and I don't understand. The great thing is the bit at the bottom there, I have n trial functions, and that corresponds to the number of qubits, and that translates into 2 to the power n grid points, right? So that's a number that goes up very, 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 very fast. So I mean, for n equals 120, I can have 10 to the power of 30 something grid points. So the idea is we're not going to have turbulence models. We're not going to worry about how you're meshing or anisotropic meshing. You just mesh the living hell out of everything. You don't do microscales, and you have all scales of motion. Regular Cartesian, boundaries are immersed, and post-processing is hell. And all of this should go into a real-world example in the context of the project. Will be a battery optimization process, CHT in that. As part of that, we want to do some adjoint optimization, so getting more and more ambitious, but we'll see how far we get. And really the reason why I'm telling you is because it's kind of interesting, but mainly we're looking for people. There's several groups looking for people. We're looking for somebody to build an interface between OpenFOAM and the quantum layer. Thank you very much.
So our next speaker is Mr. Patrick Höhn from Clausel University of Technology. He will be speaking on monthly informal OpenFOAM meeting.
Thank you for having me here today for this brief talk. Since OpenFOAM Workshop 2020, I'm hosting on Zoom a monthly meeting with, I would say, pretty fluctuating number of participants. So today I also take the opportunity to talk a bit about it. Generally, it was arising from the OpenFOAM Workshop 2020, where there was a lot of discussion about where could beginners go to, where people who don't work in a work group where OpenFOAM is used, where they could discuss. And so that was the goal, uniting the learners in the community, giving them a forum where one could discuss problems. At that point, I was also one of them. But now things have changed a little for me, but still I think it's a valuable initiative. As I said, it was since 2020. I announced the date every month at CFD Online, and the topics change really pretty much. We sometimes had beginners who are coming, whom we give some initial reading material. Sometimes we also discuss technical problems. Last time we were discussing my meshing strategy, which was apparently not so good. And yeah, it's a very small community, maybe 2-3 participants so far, max generally. So I'm just here to invite you and hoping that, yeah, a few more people can get interested. So maybe it can be also valuable, and yeah, it also gets a bit more constant. So, and there I'm pretty much open, as I say, for topics. It depends on the audience. Also, the format can change. But to make all of that happen, I need feedback from the community. What would attract more people? And yeah, that is also the reason why I'm talking here today. In all of that, also today evening, there will be a meetup. So anyone is welcome to come. Maybe we can make that thing make more attractive, more active, because I think it's a good thing to have something beside Discord where you can discuss for a bit longer time. And the next meeting is at the 23rd of July at 14 o'clock. And I hope I see some of you there. Thank you.
So our next speaker is Mr. Mirza Popovac from AIT, and he will be talking about density of frost.
Hello, my name is Mirza Popovac from Austrian Institute of Technology. And yeah, fun fact, just the other day, I bumped into an old friend of mine. Yeah, I owe him one since he introduced me to Ignaz, the blockMesh guru. And yeah, now I'm here doing the splash talk. I mean, what else can I say? Except that there was not much preparation in all of this. But the topic that I selected, one day my boss popped up and he asked, "Hey, you, what's that white thing over there?" And yeah, this too. I said, "Sir, frost, sir." He said, "Can you model this?" "Sir, yes, sir." Like you always answer to these kind of questions to your boss. So since then, I was looking at frost modeling or accretion of the frost on the evaporators of heat pumps, which is very nice topic, and it's safe to do various simplifications because the characteristic timescales involved are so different that you can simply assume assume from the flow field the variables that you need for the growth of the frost layer. Yeah, briefly sketched up in the scheme, and for that I collected from the papers, yeah, all the simplified momentum, mass, and heat transfer expressions, which boil down to something like this thing. Which is very easy and nice to solve, but they all rely on one factor, and this is the density of the frost. You typically find the expressions like this, which are purely purely empirical, but you can imagine that, of course, with the coefficients, you can influence the results strongly. And my question was, and I haven't found in literature anything, how do you measure the density of the frost? Because you can just imagine it's a crystalline structure, porous structure on low temperatures and everything. So you can imagine it's difficult to perform all the measurements. So yeah, there's no conclusion to this talk, but rather a question if you have something. Thank you.
So our next speaker is Mr. Scott Levie from UCD, and he will be talking about GMRES velocity correction acceleration scheme.
Thanks very much. So yeah, my name is Scott Levy. I'm a PhD student at University College Dublin. And for the summer, I've been working with Professor Jasak on trying to accelerate some of the iterative solvers in OpenFOAM using a modified version of the GMRES algorithm. So quickly, I apologize in advance for all the maths. The GMRES algorithm, it solves a linear system. How it does this is it guesses the solution, forms a residual, and then searches for the solution within a search space, which is a Krylov subspace, then performs more maths and finds this correction. So basically, the main idea is instead of using a Krylov subspace to search for the correction, we'll use a subspace formed from the residual vectors of previous iterations within an iterative loop. So the example I use is in a simple loop in SimpleFOAM. So what does this look like? You calculate your residual, and then you perform the same method GMRES does when you have your set of residuals. You find an orthonormal basis, and you perform this lovely least square problems, and you find a correction to your x, which in my case is the velocity field. So the results so far, I've only got these results in the last 2 weeks, so it's very much a work in progress. So laminar Pitts daily case, you can see here this is the convergence history, where I'm comparing the corrected case to a normal SimpleFOAM case. So the solid lines are the SimpleFOAM case, and then these blips are where the corrections are made. So as you can see where the corrections are made, the residuals spike and then they drop down. And when they drop down, they do become lower than the SimpleFOAM residuals, but they don't become a lot lower, and the overall iterations don't decrease. So I guess the goal would be to enhance this so that these drops would be a lot lower and so that it would converge sooner. Yeah, so a few variations of this. This is just change of viscosity. So you can see again, the residuals do seem to be lower, but they don't have an overall great effect, I suppose. Yeah, just another example. You can see the residuals are lower. So yeah, if anyone has any questions or suggestions, I'm open to them. Thank you.
Our last speaker for this session is Mohammad from Exeter University, and he will be speaking on turbomachinery in OpenFOAM.
Good afternoon, ladies and gentlemen. My name is Dr. Mohammad Moshfeghi, and I am proud that last year I was working under supervision of Professor Gavin Tabor and Professor Dave Maxey on the KTP plan for between Turin Sci-Fi Company and Exeter University. And our main purpose was to establish a platform for CFD usage for the industrial computations. You know, there are a lot of differences between industrial applications and scientific applications. Many of those trivial things that we usually pay attention in scientific investigation and research, we don't care about especially for the performance analysis of turbomachinery. Turin Sci-Fi is a company, actually that I worked there last year for almost 1 year, and they have a range of different products including these centrifugal pumps. And my plan there was to see how effective different numerical simulations, softwares or packages, and even meshing will affect the CFD results in the level that was required by the company. So I went through different investigations, different cases. I generated mesh with different packages, and I don't name them. And also I solved them with Fluent, Star CCM, and also OpenFOAM. And this was the actually code that we wrote very simple after a lot of tries, something that we could just realize that if it works permanently and constantly for all of the cases that we had, and just especially for the y plus, I use val function, but I was concerned that if someone wants to just not apply the val function, what would be the, good code for that? And what I realized that, okay, the black line is the test results, and in the middle, the point that you see the arrow is somewhere that we have another fan in the test section which applies, and we don't have the information of that fan in terms of the power consumption and etc. So up to that point, we see that all of the commercial softwares, including and also the results, the fate curves are for commercial softwares, and also the results of OpenFOAM, they were more or less less than 10% difference. And yeah, it's what OpenFOAM can do for industrial usage. Thank you so much.